Now that we've been studying quadratic equations, let's look at how to graph a quadratic. I'm going to show you two specific methods. I'm not going to go super in depth into either of them. And I'll kind of explain what I mean on each example, kind of what I could do more to make my graph even better. One thing I want to point out, though, when we're talking about graphing, is please remember I can always, no matter what kind of an equation I have, whether it's linear, quadratic, cubic, logarithmic, exponential, any kind of function, I can always graph it by picking values for x, plugging that x value in, and getting my f of x or my y value. I can do that as many times as I want, plot each of those points until I start to understand and see what my function's going to look like. However, it is a somewhat tedious method, which is why I'm going to show you a couple different ways. So far we've been looking at standard form of a quadratic equation. So let's first talk about graphing in standard form. So the first thing we're going to do is we're going to determine the direction our parabola opens, and then we're going to find our vertex. And I wrote down our vertex formula here. So as I said just a moment ago, I could be much more specific because I know how to find y-intercepts. I know how to find x-intercepts. So I could very easily find those specific points and plot those as well. The more points I plot, the better idea of the function that I'm going to get. However, I'm just going to do a quick sketch here, and I'm not going to go quite that in depth. So first thing I need to do is determine which way my parabola opens. So I notice here that because my quadratic term has a coefficient of -1, I know that it's going to open down. And then I'm going to find my vertex. So first thing I'm going to do is I'm going to find out what my b is. It's -4, so negative b over 2a is going to be 4 over, and as I just said, my a is -1. Well, that's going to give me -2, so when I write down my vertex, I have -2, comma. The vertex is a point, so I need a y value. And y is going to be the negative of -2 squared minus 4 times -2 plus 6, which is going to give me -4 plus 8 plus 6, which is going to give me 10. So my point is at -2, 10. On my graph, I won't have enough room if I don't. I'm going to count by 2s. So I'm going to go back 2 and be here. And then I'm going to go up 2, 4, 6, 8, 10. And so my vertex is going to be here. And I'm going to open down. So now again, I'm not real specific. I may or may not be very accurate here on my x and y intercepts. So again, I could definitely do a better job of graphing that if I found them as well. Looking at the second example, and the reason I'm not going to go into that detail of graphing those is because this is what I really want to hit here, is this information under option 2. We also are going to look at something that we call the vertex form of a quadratic equation. So this is going to be a little bit more helpful in graphing. This wasn't necessarily hard. However, if I'm in this form, it makes finding my vertex even easier, even faster. And not only does it make it faster, it eliminates room for error. So what I'm going to do now is I'm going to determine the direction the parabola opens. I'm going to find the vertex. In this case, my vertex is going to be much more simpler to find because I'm going to take my h value. So notice there is a minus sign in front of the h, so the sign won't belong to the number here. It's built into my equation. And I'm going to take my k value. And I'll use the absolute value of a to adjust my width. So if the absolute value of a, I should probably write this down, if the absolute value of a is greater than 1, I get skinnier. And the bigger that value is, the skinnier I'm going to get. If the absolute value of a is less than 1, and I should say between 0 and 1, let's do that. So let's do the absolute value of a is between 0 and 1 because the sign, the negative and positive, is just going to tell me the direction it opens. I'm going to get wider. And the closer to 0 I am, the wider I'm going to be. So let's go ahead and look at these. On example 1, first thing I'm going to do is determine which way it opens. I see my a here is positive, so I'm going to say it opens up. And then I'm going to find my vertex, Well, remember this is in the form x minus h squared plus k. And my vertex is going to be h comma k, so I'm going to say 3 comma 2. And it is going to be skinnier than my standard x squared parabola because of this 2 here. Again, I'm not going to be as specific as I could be. I could definitely find my x-intercept and my y-intercept here and make a really nice, good graph of this parabola. You will do some of that on some problems on this, but for now, to just show you the new stuff in this video, I'm skipping that step. Moving this up a little bit. So now I'm just going to go ahead and I'm going to plot 1, 2, 3 up 2. And it opens up. So notice on this one, I wouldn't even need my x-intercept since I'm not going to have any, but I could definitely find my y-intercept to do a better job of sketching this. But my parabola will look something like this. And looking at this second example, I am going to go ahead and here do the same thing. I see I have a negative out front, so I know I'm going to open down my vertex. So this is in the form x minus h squared plus k, and I do apologize, there should be a square on here. I missed that when I made my template. So I'm going to go ahead and find my vertex. So what is my h value? Well, my formula says I'm supposed to be subtracting h. So what value would I have to have h be in order for subtracting it to become plus? Well, if my h was -4, minus a -4 would become +4. So I'm going to say my vertex is at -4, excuse me. And then I need a plus k, so I'm adding a -1. That's what it means to subtract 1. So I'm going to say -4, -1. It is going to be wider because of this 0.4. Again, I could be more accurate by finding out additional information such as x and y intercepts. I'm going to go back 1, 2, 3, 4, down 1. And I'm going to try to make a little bit fatter parabola here. And it ends up just looking like a giant parabola, but again, I'm trying to make it wider. I probably should have made my parabola in example 1 a bit skinnier. It is a bit wide for having a coefficient of 2. If I kind of go back and edit that a little bit, should again be skinnier. So if you disregard the red, I can't erase it once I don't think, yep, it will not let me erase it because I've done some more work on this slide. But big thing is determine your direction and find your vertex. You can use that to assist you in graphing.